How are you? This is Ambish Kumar Jai speaking. Today we are going to discuss the topic kinematics. What is kinematics? In kinematics, we study the nature of motion without going into causes of motion. So let me write. We study the nature of motion. What is kinematics? We study nature. We study nature of motion. We study nature of motion without going into the cause of. We don't go into the cause of motion. Okay? We study only the motion, the nature of motion. The first term that I would like to define when we study kinematics is distance. What is distance? How we define distance? It is total path length. Distance is total path length traversed between point A and a distance. Total path length. Total path is total path length traversed by body. Path length traversed is total path length traversed by body between initial and final points. Between initial and final points. So distance is total path length traversed by body between initial and final points. We take two examples. This is A, this is O, this is B. Okay. A particle moves along this path and this path, AO plus OB. So what is the distance in distance traversed in this case when body moves from AO to OB? The distance equals to AO plus OB. This is distance, AO plus OB. This is distance. We take another example. In this case, body starts from A, completes completes a cycle. In other words, starts from A and comes back to the same position. So what is distance in this case? R. So distance equals to 2 pi r. So in this case, distance was AO plus OB. In this case, when the body makes a complete cycle, in other words, starts from point A and comes back to the same point A. So distance traverses 2 pi r. Other more features of distance. It is a scalar quantity, and distance is always positive. Okay. Another feature of distance, it is a scalar quantity. It is a scalar quantity. Distance is a scalar quantity and distance is always positive, equals to or always, and scalar quantity and distance is always positive. Okay, so this is distance. Now another very related term that we are going to define is displacement. Okay, another very important term that we are going to define is displacement. What is displacement? So displacement. Okay. Displacement, it is the shortest distance between points A between is the change in position vector. Displacement is change in displacement. It is change in position vector. Position vector. Okay. Or a vector which joins initial and final points. A vector which joins it is a vector which joins initial and final. A vector which joins initial and final points. This is displacement. Change in position vector. So it as a self-evident, displacement is a vector quantity. So a vector is a vector, and it can be positive, negative, and zero. It can be positive, negative, or zero. Okay, it's positive, negative, or zero. And distance. What is the relation between distance and distance? Will always be greater than or equal to displacement. So distance is always greater than or equal to it is always greater than or equal to displacement. So you have defined two conditions, two features of kinematics: the distance and displacement. Distance is total path length traveled, and displacement is a vector, position vector that connects initial and final points. Okay. So, and distance, it is always greater than or equal to displacement. Displacement is a vector quantity which can be positive, negative, or zero. Okay, we are taking examples, two more examples. Okay. In this case, okay, body moves from A to B, A to O, and then from O to B. So, and this is right angle triangle. That is, they make 90 degree with each other. So, what is displacement in this case? Displacement. How to obtain displacement? We'll use Pythagoras theorem. That is, AB square equals to AO square plus OB square. So, AB equals to AO square plus root under. We have obtained this using Pythagoras theorem. So this is the shortest distance between A and B, and we obtain AB equals to Pythagoras. So this is displacement. AB equals to AO square plus OB square. This is displacement. Because what was distance? That was AO plus OB. Okay. Now we take another example. Okay. Distance is greater than displacement. Okay. Now another example is a body moves from position A and comes back to the same position, completing a circle. Body moves. Body moves from position A, moves from position. It moves from position A and comes back to the same point, to the same point. It comes to the same point, completing a circle. Completing a circle. So in this circuit, body moves from point A and comes back to the same position A by completing the circle. So what is displacement in this case? In this case, displacement equals to 0. Displacement equals to 0. So this is the difference between, fundamental difference between distance and displacement. Okay. Now we are going to define other quantity parameters, other physical quantities which are related with distance and displacement. Now we are going to define what is speed. Okay, we are going to define what is speed. What is speed? It is change in position, okay, with time, or you could say rate of change of position. So the speed is the rate of change of, it is rate of change, it is rate of change of, is rate of change of position, rate of change of position, that is called speed. And so how now we'll how to define average speed. Average speed, average speed equals to total path length traveled. So we just saw what is the distance. So it is total path length traveled. Total path length, path traveled total path length traveled divided by total time. So this is speed, rate of change of positions. Speed, mathematically we define average speed as total path travel, total path length travel divided by total time taken. So this is our average speed. Now we take, so what are the properties of average speed? Speed is again a scalar constant. It is always positive. Speed, it is a scalar quantity. Speed is a scalar quantity. It is a scalar. It is a scalar quantity. It is a scalar quantity, and it is always positive. And it is always positive. So speed is, it is a scalar quantity, and speed, like distance, speed is always positive. Now we have defined speed. Now we are going to define velocity. What is velocity? Velocity is change of position in a definite direction, because velocity is a vector. Velocity is vector. So what is velocity? It is rate of change, velocity, rate of change of position in a definite direction. Definite direction. Velocity is rate of change of position, rate of, it is rate of change of position. It is rate of change of position in a definite direction. Position in a definite, rate of change of position in a different direction. So it is rate of change of position in a definite direction. So now we have defined velocity, and again, what is average velocity? average velocity. It is displacement, total displacement upon total time taken. Total displacement upon total time, or you could say this is total xf minus xi upon tf minus ti. So this is our average velocity, total displacement upon total time taken. And again, since velocity is a vector, so average velocity is a vector. So it is a vector quantity. Displacement, velocity is a vector quantity, and velocity can be positive, negative, and is positive, negative, and zero. Okay? So this is positive, negative, and this is velocity. And again, speed. What is the relationship between speed and velocity? Speed will always be greater than velocity. Velocity and speed always greater than or equal to velocity. Speed is always greater than or equal to velocity. I think this is wrong. Now next term we have defined distance, we have defined displacement, we have defined speed, and we have defined velocity. Now we are going to define what is instantaneous speed and what is instantaneous velocity. What is instantaneous velocity? First we'll define what is instantaneous velocity. That is rate of change of instant velocity. Instant velocity is rate of change of position at an instant. That we are defined instantaneous velocity. What is instantaneous velocity? Rate of change of position at an instant is rate of change of position. It is rate of change of position at an instant. Position at an instant. Rate of change of position at an instant in a definite direction. Instant in a definite direction in a definite direction. Rate of change of position at an instant in a definite direction. With direction with some time interval, and the time interval is infinitesimally small in a different direction. So rate of change of position. So instantaneous velocity. First we define average velocity. Average velocity equals to delta x upon delta t. So this is average. This is definition of average velocity. It is delta x upon delta t. When delta t becomes 0, that is delta t becomes infinitesimally small. When delta t tends to 0 or delta t becomes infinite, it becomes infinitesimally small. when delta tends to 0, or it becomes infinitesimally small. So this then it becomes instantaneous velocity. So instantaneous velocity. So what instantaneous velocity equals to del x upon del t, delta t tending to 0 equals to dx upon dt. So this is instantaneous velocity. That is the first derivative of position graph. Okay, this is the first velocity. This is the first derivative of position graph. So this is instantaneous velocity. We define average velocity, and we define the average velocity, which is rate of change of position at a given time interval. And then we make that time interval infinitely small. We make that very small, and then that becomes instantaneous velocity. Now we define what is instantaneous. Instantaneous velocity. Instantaneous speed is nothing but magnitude of instantaneous velocity. Instantaneous speed. Instantaneous. Instantaneous, it is a magnitude. It is magnitude of instantaneous velocity. Instantaneous. It is magnitude of instantaneous velocity. What it means to say instantaneous speed equals to, what we say, instantaneous speed equals to del x upon del t, limit delta t tending to 0, we take mod, so that means to say the magnitude of instantaneous velocity, or dx upon dt, or slope. So instantaneous speed is basically magnitude of instantaneous velocity. This is delta t tending to 0, and when we take delta tending to 0, it becomes dx upon dt. Okay. Now we define average velocity, average acceleration. Another very important term that we'll be using. Average acceleration. What is average acceleration? It is ratio of change in vector divided by time t. Ratio equals to AV is average velocity is ratio of change in velocity, ratio of change in velocity, ratio of change in velocity to time taken to time interval, velocity to time interval. So average acceleration, ratio of change in velocity to time interval. So we can write A average equals to delta v upon delta t, or Vf minus Vi, or Df minus Di. This is how we define average acceleration. So again, this is average acceleration from, and now how we define instantaneous acceleration. So instantaneous at an instant equals to del v upon del t, limit delta t tending to 0 equals to dv upon, that is the first derivative of velocity. So this is instantaneous acceleration. Okay. So we have defined average acceleration, we have defined instantaneous acceleration. Now we'll go for some graphical representation of motion. graphical. Now we're going for graphical representation of motion. Okay. Now we define some graphical representation of motion. Understanding. Now we try to understanding we are trying to understand motion, understanding motion graphically. We try to understand motion graphically. Okay. First we take displacement. Okay. Yeah. Displacement. Now, first condition is body at rest. First condition is this body at rest. We understand we are trying to understand motion graphically. First condition is body at rest. Means body at rest. What is displacement? Okay. So what is displacement? Right. Let me draw displacement timeline. Displacement time graph. This is T. This is X. Okay. It's T. This is X, or you can take Y. So displacement, body is at rest. So we take some position X. So this is XC. We can take some constant value from the reference point. Okay. And so the value is constant. So this is displacement graphically. This is displacement. Now next time we are going to define graphically is rest velocity. We take velocity. We take velocity V and T. Okay. V and T. So when the body at rest, what will be velocity? It will be 0, obviously. So when the body at rest, the velocity will be 0. Same with acceleration. Okay. Now we define third. This is velocity. This is C. Acceleration. This is time. Acceleration. Some reference point. So it moves like this. It moves like this. Acceleration is 0. When the obviously acceleration is 0 and velocity is equals to 0, the body is at rest. Second thing we are going to design uniform velocity. Second thing that we are going to study is motion constant velocity. Motion with constant velocity. That is motion with constant velocity. We want to study motion with constant velocity. Underline. We study motion with constant velocity. Okay, what happens here is that motion with constant. So first we will study displacement. Okay. Zero. This is X. Yeah, this is time T. So we have motion velocity is constant. So velocity equals to x minus x0 upon t minus, we take a time t equals to 0. So what happens? X equals to vt plus x equals to vt plus x0. And what is this? This is equation of a straight line equation of a this is the equation of a straight line. Okay, y equals to mx plus c. This is t. So when we plot it graphically, the displacement at time. So we take some position x0, and this is the motion. This is the graph for displace. This is the graph of displacement. And the motion is with constant velocity. Okay, that is uniform motion. Uniform. Next term that we are going to define is velocity. Velocity is constant. We are moving constant velocity. We are going to move with constant velocity. Okay. So what happens when the body moves with constant velocity? It's the velocity time as this is moves with constant velocity. So we take some case. Okay. Show velocity v0. This is velocity is constant with time. So this is the graphical representation of velocity, which is constant with time. Now we define acceleration. How we define acceleration is rate of change of velocity. So when the velocity is constant, there is no change in velocity. So acceleration equals to 0. Acceleration equals to 0. So what we get is that this is a, this is t, this is acceleration, this is, and we have acceleration is 0, right? So this is the graphical representation. So this is the graphical representation. Acceleration is 0. Okay. Now we study acceleration. Okay. Motion with constant acceleration. Now we study motion with constant acceleration. So we are going to study motion with constant acceleration. Okay. Acceleration is constant. So we will be deriving three equations of kinematics when motion is constant, or in other words, motion is uniform, constant acceleration. So we have three equations. X equals to ut or u0t plus half at square. V equals to u0 plus at. We'll be using these two equations. Okay. So this is equation x equals to u0t plus half at square. This is the equation of a parabola. Equation of a para. This is the equation of a para. So this equation is equation of a para. Second order quadratic equation. Okay. So this is x. This is t. Okay. Motion with constant acceleration. So position vector. Let me write here. Displacement actually. So I'm rubbing it so that things will be more clear. Motion first is displacement. Okay. What is displacement? When the motion is with constant acceleration, motion it is a parabola. Okay. X in time, and it is a parabola, and x equals to 0t plus half a t square. This is the equation. When position time graph, it is a parabola, second order, equals to parabola. It is a parabola which is second order quadratic. So it is x equals to u0 t plus half a t square. It is a parabola which is second order quadratic equation. Okay, this is displacement. So the motion is with constant acceleration. Okay, now second case is velocity. What is velocity time graph? Second case is the velocity. So acceleration is constant, so we are going to use the equation v equals to u0 plus at. Okay, so this is in the form of v0 or at plus this is equivalent to y equals to mx plus c. This is the equation of a straight line. Straight line. This is straight line equation. Okay, y equals to mx plus c. Draw it. This is velocity. This is time graph. So we take some initial velocity u0, and this is straight line. This is the nature of velocity time graph when acceleration is constant. Now, third case is what is the nature of acceleration time graph. Third case is what is the nature of acceleration time graph. Okay, acceleration time graph. So acceleration. Third case is acceleration. Okay, so acceleration is constant. This is t. This is a. So we take some value of acceleration a0, and this is the graphical representation. This is when the acceleration is constant. This is a versus time graph, acceleration versus time graph, and the curve is a straight line. Thank you.